Let me start with something so ordinary that you would never question it. You kneel down, press your hands into the soil. Maybe you are pulling a weed. Maybe just breaking apart a clump of earth. And in your mind, this is simple, mechanical, almost boring. Just friction, pressure, skin against dirt. Nothing more than a casual interaction between you and the ground. But the moment your skin makes contact, something begins that does not belong to the world you are used to thinking in. Because at the scale where that contact actually happens, the rules you rely on no longer apply in the way you expect. You think you are touching a solid surface, but there is no such thing as perfect contact, not in the classical sense. Not when you zoom down far enough, because what you call touch is really the interaction of electromagnetic fields, the repulsion between electron clouds, and those electrons do not behave like tiny billiard balls sitting neatly in place. They exist as probability distributions, spread out, uncertain, governed by the same equations that describe particles tunneling through barriers they should not be able to cross. Now here is where it becomes uncomfortable. Because electrons do not simply stay confined to your body or the soil. They move. They transfer. And at these microscopic boundaries, quantum tunneling allows electrons to pass between molecules, even when classical physics would say the barrier is too high, too thick, too impossible. When your skin presses into the ground, electrons begin to shift across that boundary, not in a clean, predictable stream, but as a result of countless probabilistic events happening simultaneously, each one tiny, each one insignificant on its own, yet together forming a measurable exchange between your body and the earth beneath you. You are not just touching the soil, you are participating in a continuous transfer of charge, a redistribution of electrons driven by differences in potential, by the structure of molecules, by the geometry of atoms arranged in proteins, lipids, minerals, and water. The outer layer of your skin, what you think of as a protective barrier, is not sealed, not closed, but dynamically interacting with its environment. And the soil is not inert either. It is a complex matrix of minerals and organic matter, each surface carrying its own electronic properties, its own capacity to accept or donate electrons. At that boundary, there is no sharp line where you end and the soil begins. Only a region where interactions happen, where electrons are shared, where the distinction between two systems becomes less about separation and more about exchange. And this is not a metaphor, not a poetic way of describing connection. This is physics, measurable, repeatable, governed by the same principles that explain how semiconductors work, how chemical reactions proceed, how life itself maintains its structure against the tendency toward disorder. You might still want to hold on to the idea that this is a minor detail, that whatever happens at the quantum level averages out and becomes irrelevant to your experience. But that instinct is exactly what prevents you from seeing what is really going on. Because the macroscopic world you trust is built entirely from these microscopic interactions, layer upon layer, scale upon scale, until something as simple as placing your hand on the ground becomes the sum of processes you cannot see but cannot escape either. So when you press your fingers into the soil, what exactly are you doing? You are still there, your hands in the soil, but something else is happening that you are not paying attention to. Something quieter, slower, and far more consequential than the moment of contact itself. Because while you are focused on what you are doing to the ground, your body is already doing something to it in return. Your skin is not a fixed surface, not a stable boundary that stays intact while you move through the world. It is constantly breaking down, constantly renewing. And every hour you spend outside, you are shedding roughly 30,000 dead skin cells without noticing, each one carrying fragments of your DNA, your proteins, your lipids, the molecular record of what your body has been. Those cells do not vanish when they leave you. They fall directly into one of the most biologically active systems on the surface of this planet. And the moment they land, they stop being you in any meaningful sense and become raw material in a process that has been running long before you were born. Soil is not empty, not passive, but densely populated with microorganisms that are already prepared to take apart whatever enters their environment, and your cells arrive, not as something special, not as something recognized as human, but simply as organic matter containing carbon, nitrogen, phosphorus, and energy. The first structures to break are the outer membranes, the thin phospholipid layers that once held each cell together, and soil bacteria release enzymes that cleave these membranes apart, separating the phosphate heads from the lipid tails and releasing phosphorus into a form that plant roots can absorb almost immediately. Inside what used to be your cells, your DNA does not persist as identity. It is dismantled by bacterial nucleases, the long chains of nucleotides broken into smaller components, and the nitrogen locked inside those bases is transformed step by step, first into ammonium, then into nitrite, then into nitrate through the activity of nitrifying bacteria that specialize in this exact conversion. That nitrate, which hours ago was part of the genetic structure that defined your skin, is now indistinguishable from any other nutrient in the soil, available to be taken up by plant roots, incorporated into amino acids, into proteins, into entirely new living structures that have no memory of where those atoms came from. Carbon follows alongside, metabolized by microorganisms that use it as fuel. Some of it released back into the atmosphere as carbon dioxide, some of it built into microbial biomass, and some transformed into stable organic compounds that will remain in the soil far longer than your cells ever lasted on your body. Nothing in this process pauses to acknowledge origin. Nothing preserves the boundary you instinctively believe exists between your body and the environment, because at this scale there is no category called self. Only chemical structures entering pathways that convert them into something else. The bacteria do not know that the material came from you. The enzymes do not discriminate, and the pathways do not branch based on identity, only on what reactions are thermodynamically possible. And all of this begins immediately, not after decay, not after death, but while you are still there, kneeling in the garden, still thinking of yourself as separate from the ground beneath you. 30,000 cells per hour, each one entering a system that does not store them, does not preserve them, does not wait. If you take a single teaspoon of healthy garden soil and hold it in your hand, what you are looking at does not resemble what it actually is, because your eyes register it as uniform, dark, almost featureless matter, while in reality that small volume contains a density of life that exceeds anything you normally associate with the word environment. Between 100 million and 1 billion bacteria inhabit that space, not scattered randomly, but organized into structured communities, layered across microscopic gradients of moisture, oxygen, and nutrient availability, coexisting with fungal networks, protozoa feeding on bacterial populations, nematodes moving through water films, between particles, and microarthropods that would only become visible if you magnified the scene far beyond what your senses can resolve. This is not just a collection of organisms. It is an active biochemical system And everything that enters it is immediately processed through pathways that are both ancient and highly efficient. The skin cells you shed do not sit idle. They are broken apart by enzymes released into the surrounding environment. Molecules designed with specific functions, each one targeting a particular type of chemical bond. Phospholipases dismantle cell membranes. Proteases cut proteins into smaller peptides and amino acids. Nucleases degrade DNA into nucleotides, and each of these fragments becomes input for another reaction, another organism, another stage in a network of transformations that never truly stops. Carbon and nitrogen, the two elements that form the backbone of your biological structure, are routed through parallel but interconnected cycles. Carbon compounds are oxidized by microorganisms that extract energy from them, incorporating part of that carbon into their own cellular structures while releasing the rest as carbon dioxide, returning it to the atmosphere where it can be taken up again by plants. Nitrogen, more complex in its transformations, is first released as ammonium when organic molecules are broken down, then oxidized into nitrite and nitrate by specialized bacteria that derive energy from this conversion, effectively turning what was once part of your body into a form that plant roots actively seek out and absorb. There is no waste in this system, only transitions. And what you perceive as decay is simply the reorganization of matter into configurations that remain chemically useful. Even the color of the soil, that deep, almost black richness, reflects the accumulation of humic substances. Stable organic compounds formed through repeated cycles of decomposition and synthesis, molecules that can persist for decades or longer, influencing the structure, fertility, and water retention of the ground beneath your hands. And then there is the smell, something so familiar that you rarely question it, that distinct, clean, slightly sweet scent that rises when you turn the soil or when rain hits dry ground, a smell that seems almost comforting without you knowing why. That scent is not an abstract quality. It is caused by a specific molecule called geosmin, produced by soil bacteria, particularly those in the genus Streptomyces, organisms that play a key role in breaking down organic material. The human nose is extraordinarily sensitive to this compound, capable of detecting it at concentrations of just a few parts per trillion, making it one of the most easily recognized chemical signals you will ever encounter. When you smell soil, you are not just sensing earth. You are detecting the metabolic output of microorganisms actively processing organic matter, including the cells you have shed, the plant material that has fallen, and countless other biological remnants that have entered this system before you. That scent is evidence of ongoing biochemical activity, a signal that decomposition is not absence but transformation. It's not an end but a continuation under a different set of rules. What you hold in your hand is not dirt in any simple sense, but a dynamic interface where chemistry, biology, and physics converge into a system that continuously rebuilds itself from whatever enters it, including you. What you have been imagining so far, even after everything we have uncovered, is still incomplete, because you are probably picturing soil as a dense but somewhat static mixture of organisms and reactions happening in place, each bacterium consuming, each molecule transforming, but largely confined to its immediate surroundings. That picture is already more complex than what most people carry in their minds, but it still misses the structure that gives this entire system its coherence. Because beneath the surface, threading through every layer of soil, there exists a network that does not stay in one place, that does not operate locally, but extends outward, connecting one point to another across distances far larger than anything you would expect at that scale. These are fungal hyphae, microscopic filaments, thinner than a human hair, growing through the soil in every direction, branching, fusing, and forming what is known as a mycelial network, a structure that functions not merely as a support system for fungi, but as a connective infrastructure linking plant roots to one another and to the microbial communities around them. This network has been evolving for hundreds of millions of years, long before animals walked on land, long before anything with a nervous system existed, and yet it performs a role that, in some respects, ressemble communication, transport, and coordination across a distributed system. When a plant root intersects with this network, a symbiotic relationship forms, mycorrhizal associations in which the plant supplies carbon compounds produced through photosynthesis to the fungi, and in return the fungi extend the plant's reach into the soil, accessing water, phosphorus, nitrogen, and other nutrients that would otherwise remain out of reach. But the exchange does not stop at simple trade, because the network connects multiple plants simultaneously, allowing resources to move from one organism to another depending on conditions, gradients, and needs that are encoded not in intention but in biochemical signaling and transport dynamics. Experiments in forest ecosystems have shown that trees linked through these fungal networks can transfer carbon to one another, with shaded individuals receiving resources from those with greater access to sunlight, and plants under attack from insects sending chemical signals through the network that trigger defensive responses in neighboring plants before the threat physically reaches them. The system does not think, it does not decide, but it responds in ways that distribute resources and information across a connected web, altering the behavior and survival of organisms that appear from above ground to be separate and independent. Now consider what happens when you push your hand or a tool into the soil, when you break apart a section of ground, because in doing so, you are not just disturbing a passive medium. You are severing thousands of these microscopic connections, cutting through threads that have taken days or weeks to grow, interrupting pathways along which nutrients and signals were moving. The network does not collapse. It adapte, because new hyphae extend from the broken ends, sensing chemical gradients, growing toward nearby roots, reestablishing connections with a persistence that reflects how fundamental this structure is to the system as a whole. When you plant something, when you press soil around the roots of a seedling, you are not placing it into isolation. You are inserting it into this existing network, giving it access to a system that predates any human activity, any agriculture, any awareness you might have of what lies beneath your feet. The plant does not start alone. It becomes part of a web that was already there, already active, already exchanging matter and information long before you arrive. If you could remove the opacity of the ground and watch only what happens below the surface over time, you would not see stillness. You would see a continuous restructuring of connections, a living web forming, breaking, and reforming, carrying materials, transmitting chemical signals, integrating whatever enters into its pathways. The garden, as you perceive it, is only the visible expression of a system whose real activity is hidden, distributed, and constantly in motion beneath you. Up to this point, you might still be holding on to one last boundary, one final line that feels safe to keep. The idea that whatever exchange is happening between you and the garden is limited to the moment your skin touches the soil, that the interaction begins at contact and ends. When you pull your hand away, that everything else remains contained within your body. But that assumption does not survive very long. once you shift your attention slightly upward into the layer of air that sits just above the ground, because that space, which appears empty and inactive, is in fact filled with a constantly changing mixture of particles, gases, and biological fragments moving between the soil and your body in both directions at the same time. The surface of the soil is not a sealed boundary, it is an interface. And from that interface, microorganisms release volatile organic compounds into the air, small molecules capable of evaporating and dispersing into the space you are breathing. At the same time, the bacteria living on your skin respond to the presence of soil organisms by altering their own metabolic activity, producing their own set of volatile compounds that enter that same shared air column. This creates a localized chemical environment around you, a dynamic zone where compounds from soil microbes and compounds from your own microbiome mix interact and circulate continuously. When you inhale, you are not just taking in oxygen and nitrogen, you are drawing in traces of these microbial metabolites, molecules that can pass through your respiratory system and enter your bloodstream, while others settle onto your skin and interact with the microorganisms already living there. Some of these compounds have antimicrobial properties, some influence, inflammation, and some participate in signaling pathways that affect how your immune system responds to the environment. None of this requires conscious awareness. None of it depends on whether you notice the smell or the sensation, because it operates at a level where chemistry drives the outcome regardless of perception. At the same time, your body is contributing to this exchange in ways that are just as constant and just as invisible. Every movement, every shift in position, every breath you exhale releases particles, moisture, and compounds into the air that settle back onto the soil surface, feeding into the microbial system below. The distinction between what belongs to you and what belongs to the environment becomes increasingly difficult to define, not because the categories are philosophically unclear, but because the physical processes involved do not respect those categories in the first place. Researchers studying outdoor environments have measured this transfer directly, tracking how microbial populations and their chemical byproducts move between soil, air, and human tissue during activities like gardening, showing that the exchange is not incidental but continuous. Not a rare event, but a baseline condition of interaction. The air you occupy while working in a garden is not neutral space. It is an active medium through which biological and chemical information flows, linking your body to the ground even when there is no direct contact. What you experience as being outside is, at a physical level, immersion in a system that extends beyond the visible surfaces you can point to. A system where boundaries are defined not by edges but by gradients, not by separation but by rates of transfer. The idea that you are a contained entity moving through an external environment begins to lose its clarity when every breath, every exposed surface, every microscopic exchange is constantly redistributing matter and information between you and everything around you. There is no precise location where your body stops and the garden begins. Only a region where the exchange becomes too small for you to notice. By now you have followed the exchange of matter, the movement of atoms, the transfer of molecules between your body and the soil, and it may already feel as though the boundary you rely on has been dissolved at the level of chemistry and biology. But there is still another layer beneath all of that, one that does not depend on enzymes, cells, or metabolism, because even if you stripped all of that away, the interaction would continue at the level of charge. The earth beneath you is not electrically neutral in the way you might casually assume. It carries a persistent negative charge maintained by the continuous electrical activity of the planet, with thousands of lightning strikes every minute, depositing electrons into the ground and sustaining a reservoir that is effectively vast compared to anything your body can hold. Your body, on the other hand, is not in equilibrium with that reservoir, because through normal metabolic processes, through oxidation, through constant contact with materials that insulate rather than conduct, you accumulate a slight positive charge relative to the ground beneath your feet. This difference is small, but it is real, measurable, and as long as it exists, it creates the conditions for a fundamental physical process to occur. The moment a conductive path is established, when your bare skin comes into direct contact with the soil, especially through areas of higher conductivity like your hands and feet, that path is formed and electrons begin to flow from the earth into your body along the gradient created by that difference in potential. This is not a special case, not a unique biological phenomenon, but the same principle that governs electrical circuits everywhere, described by Ohm's law, where a voltage difference across a conductive path produces a current. The only difference here is that the circuit includes your body and the surface of the planet, and the current is composed of free electrons moving into tissues that are already engaged in countless chemical reactions sensitive to the presence or absence of those electrons. Inside your body, one of the persistent challenges at the molecular level is the presence of reactive oxygen species, often referred to as free radicals, molecules that contain unpaired electrons and therefore seek stability by extracting electrons from nearby structures such as cell membranes, proteins, and even DNA. This process, when it exceeds the capacity of your internal antioxidant systems, contributes to oxidative stress and inflammation, gradually damaging tissues over time. The introduction of free electrons from an external source provides a direct way to neutralize these reactive species, because a single electron can pair with the unpaired electron in a radical, stabilizing it and preventing further damage. When electrons flow from the ground into your body, they do not carry intent, they do not target specific molecules, but they become part of the overall electron pool available for chemical interactions, increasing the likelihood that reactive species will be neutralized before they can propagate damage through chain reactions. Studies that measure physiological markers during direct contact with the earth have observed changes consistent with this mechanism, including reductions in cortisol levels, shifts in heart rate variability toward patterns associated with parasympathetic activation, and decreases in markers of systemic inflammation, all occurring within relatively short periods of sustained contact. None of this depends on belief or perception, because the underlying process is indifferent to whether you are aware of it, and it does not require a complex pathway to operate, only a difference in charge and a conductive connection. The simplicity of the mechanism is precisely what makes it difficult to accept, because it suggests that something as ordinary as placing your hands on the ground can alter internal conditions through direct physical interaction rather than through indirect behavioral or psychological effects. The system does not pause to consider context. It does not scale its operation based on significance. It follows the same rules everywhere, from engineered circuits to the surface of your skin, from laboratory measurements to the quiet moment when you kneel in the garden and press your palms into the soil, completing a circuit that was already waiting to be closed. There is one more layer to this, and it does not sit outside you or beneath your hands or in the air you are breathing, but inside every cell in your body, operating quietly, continuously, marking time in a way you were never meant to feel directly. Because while you are exchanging atoms with the soil and electrons with the earth, your cells are carrying a record of how long they can keep going. At the ends of every chromosome there are structures called telomeres, repeating sequences of DNA that do not code for proteins but serve as protective caps, preventing the genetic material from degrading or fusing with neighboring strands. And each time a cell divides, these caps shorten slightly because the machinery that copies DNA cannot replicate the very ends completely. This shortening is not dramatic in a single event, but it accumulates division after division, year after year, until eventually the telomeres reach a critical length and the cell either stops dividing or enters a state where it remains alive but no longer contributes to regeneration in the same way. This is one of the mechanisms through which aging expresses itself at the cellular level, not as a sudden failure, but as a gradual loss of capacity, a narrowing of what is still possible for the system. And yet, even here, the process is not entirely fixed, because environmental conditions can influence how quickly this shortening occurs and whether it can be partially counteracted. When your skin is exposed to sunlight, specifically ultraviolet B radiation, it initiates the synthesis of vitamin D, which is then converted into an active hormone that participates in multiple regulatory pathways, including the activation of an enzyme called telomerase, capable of adding sequences back onto the ends of telomeres, slowing the rate at which they shorten, and in some cases, restoring a portion of what has been lost. So while you are outside, hands in the soil, body exposed to the sun, there are simultaneous processes unfolding at completely different scales. Your cells adjusting their internal chemistry in response to light, your tissues receiving electrons from the ground, your microbiome exchanging compounds with the air and soil. And all of these interactions converge on the same underlying reality that your body is not a closed system moving through time unchanged, but an open system constantly being rebuilt from the materials and energy flowing through it. The carbon that forms the structure of your body does not remain with you indefinitely. It cycles, moving from your cells into the soil through shedding and respiration, entering microbial pathways, becoming part of bacterial biomass, or returning to the atmosphere, then being drawn into plants through photosynthesis, incorporated into sugars transported through stems and leaves, and eventually entering the bodies of organisms that consume those plants within a matter of weeks or months. Atoms that were once part of your skin can be found in the tissues of something growing nearby. And when you eat, when you breathe, when you drink, atoms that were part of the environment re-enter your body, becoming part of you without carrying any trace of their previous form. There is no moment when this cycle begins and no moment when it ends, because it is already in progress. And it does not wait for the event you call death to initiate the return of your body to the earth. The process is continuous, distributed across time, occurring with every cell you shed, every molecule you exhale, every nutrient you absorb. And the only thing that changes at the end of life is the rate at which the remaining structures are broken down and reintegrated into the system. If you follow the path of a single carbon atom long enough, it will pass through soil, through plants, through animals, through the air, and through bodies like yours repeatedly. Never fixed, never owned, only temporarily organized into structures that persist for a while before dissolving into something else. What you call your body is one of those temporary organizations, a pattern maintained for a limited time by continuous input and output, by energy flow, by chemical gradients that allow structure to exist against the tendency toward disorder. You are not separate from the garden, not eventually connected to it, not destined to return to it at some distant point, but already participating in the same cycle, already composed of the same materials, already subject to the same rules that govern how those materials move and transform. The distinction you feel between yourself and the soil is not written into the physics. It is a feature of perception, a boundary that exists at the level of experience, but not at the level of atoms, not at the level where the processes you have been following actually occur. You are not a fixed thing that will one day become part of the earth. You are a temporary arrangement of matter that has always been moving through it.